This is lesson 6.4, Application of Systems, also known as story problems, which is everybody's favorite. Make sure you've got some graph paper and a ruler. If you have a graphing calculator, that's very helpful, but it's not necessary. In fact, I'm going to show you how to use the graphing calculator one more time, and then you can use it when you get to class. Here we go. The learning target today is to choose the best method and solve a linear system for story problems. Remember to set your paper up with Cornell notes. This is lesson 6.4 on applications. You can write story problems and then set up your essential question. Remember, the essential question comes from the learning target, so hit the pause button, get all that set up, and then hit resume when you're ready to go. Okay, so far you've learned three methods: the graphing method, substitution, and elimination. And remember, the graphing method was used especially when you had equations that looked like this. They're already set up in the slope-intercept form, or the y equals mx plus b. You simply graphed the equations, and where the two lines crossed is your solution. That was the first method. And generally, you're going to use the graphing method when you want a visual display or when you're trying to estimate a solution. And if the numbers come out to be nice whole numbers, the graphing method is the best method to use. But if they're not whole numbers, it's not as easy to identify where they intersect. In the substitution method, that's the second method you learned, it was best when one of the equations was already solved for one variable. For example, this set of equations, y equals 3x, is already solved for y. You're going to substitute that value in for y and get a solution that way. The last method that you learned was the elimination method, and it worked best anytime you had two variables that were exact opposites. In this problem, negative y and positive y are exact opposites. They will cancel each other out or eliminate. So solving this system to get a solution, it's best to use the elimination method because the two y variables will cancel each other out. Okay, you can use any of these methods in this lesson. The goal is to solve a system for a story problem and use the method that works best. Now, I've explained a little bit in class what it means to break even. I wanted to give you just a little bit more of an explanation. Basically, break even happens when your income, the amount of money that you bring in, equals your expenses. That's the amount of money that you pay out. So let's say you're going to start your own business. You're going to start a lemonade stand. Now, in order to start a lemonade stand, you can't just walk up and start selling lemonade. You're going to need some supplies. For example, this beautiful wooden lemonade stand might cost money to build. And then you're going to need cups. And then you might need paint or markers to make signs. So there are supplies that go with starting up a business. So your expenses, the amount of money that you pay out, might involve some cash up front. So let's just say $50 to buy stuff. Stuff to make the lemonade stand, stuff to paint signs, and cups to put your lemonade in. And then you might sell the lemonade, but it's going to cost you money to make the lemonade. So maybe it's 10 cents per cup to make lemonade. Well, the information for the expenses can create an equation that looks like this. Y equals the total amount of expenses, and that's going to be equal to a rate, 10 cents per cup, X will represent cups, plus $50, that's the startup cost to buy the stuff. Okay, so you've got your lemonade stand. Now you're ready to start making money and start earning income. The income comes from the money that you earn when you sell the lemonade. So the total amount of money, Y, will be equal to 25 cents for every cup that you sell. That's your income. When you break even, your expenses will equal your income. Now what does that look like on a graph? Well, here's a picture. The break-even point is where the two lines will cross. In this picture, the income is the blue line. It starts at 0, and every cup of lemonade you sell earns you income. The red line is the expenses. It starts with, in this case, the $50 that we started with to make our lemonade stand and signs. And it's going to cost us money to make each cup of lemonade. At this point, where the two lines cross, that's your break-even point. Everything before that point means you're losing money. You're spending more than you're earning. Everything beyond that point means you're making money. You're making more money than you spend. Okay, that's just your mini economics lesson to get you started with today's problems. So, first problem that you should write down is problem 1, and here's what it says. A fashion designer makes and sells hats. The materials for each hat costs $5.50. The hats sell for $12.50 each. The designer spends $1,400 on advertising. How many hats must the designer sell to break even? Now, the break even in this question is your indicator that you're going to be dealing with a problem that has two equations, one for income and one for expenses. So in general, if you see a break even in the question, you're going to want to set up two equations like this. So you look through the problem and you decide, where are my expenses? Well, the first expenses is in this sentence that says material for each hat costs. So start your equation with the total amount of expenses, Y, equals $5.50. $5.50. Now is that $5.50 once, or does that $5.50 happen more than one time? And the answer is, in this case, it happens for every single hat. So that's multiplied by X, which is the number of hats. Are there any other expenses? Anything else that you have to pay out? And again, the answer is yes. The designer spends $1,400 on advertising. So in addition to each hat costing $5.50, there's also an expense of $1,400. Okay, how about income? How much money do I bring in? Well, the total amount of money, Y, will be the amount of money that is income. And that happens every time a hat sells, $12.50 each. So it's $12.50 for each hat. And that's it. Those are the two equations. Now, because these two equations are written in the y equals mx plus b form, it's going to be easiest to graph it.